Let's have a look at equation with logs. So here we have to solve the equation, meaning we have to find the value of n, and n, that's where it is here, and that's where it is. Now, one thing that has to do with the equation that involves log, we kind of have to know where we are going, what are we trying to achieve with our equation. So in order to solve equation with logs, we have two main ways of doing it. There is a third way, not as common, but two ways. The two main ways is that our equation can either have the form when I have log, then I have the base of that log, I have a product, and on the other side, I have power. So what do I mean by that? So let's say like here, that is my base, that is my product. Well, obviously I have a little bit more, so I'm not there yet, but I'm saying if I could have that n equal and then some form of a number on the other side, then in this case, I take my base to the power that I have on the other side, and that means the outcome of that is the product. Now, the other way that we can as well solve is when I have log, base, and product. Now, one thing, sorry, I should have mentioned here that I need to have that on its own. No numbers here, nothing here. So the same, if I have just the log with the base and product, nothing else on this side of the equation, and the same on the other side of the equation. Then there is a condition. If base on one side of my equation is the same as base on the other side of the equation, then what I can do, I can take one product and equal that to the other product. So that's generally the way we go. Now, that third way, the best is to explain that on a specific example is by substitution. There are videos like that, but here we're not going to be bringing that. So I'm saying, okay, if that's where I'm going, I'm saying at the moment, none of these, that's not what I have. So I'm saying, I do have a number on the other side, but I have two logs here. So one of my question is, can the two logs just become one log? Because here, I could move this log to the other side, but the problem is that I still have that 2. I can't just ignore it, okay? So I'm saying, can I achieve that? How do we achieve that? Well, we go to the table and we look for the formula. Because formulas in our table, basically what they are for, they are telling us that something is written in one way, but can be replaced and written in a different way. So let's have a look at the formulas to see which of them reflects the situation I have in my particular example. Let's take that maybe here so that we can compare. So I have log minus a log. So I can see I have a formula here. I'm saying, okay, I have a log, have to be the same base. I have the same base. Then product can be different. That's fine. The problem I'm having is that this log does not allow for a number. But I have a number here in front of the log. So first, I need to eliminate that number from here. So again, I'm looking for the formula. Is there a log with the number in front? And yes, there is. The next formula is telling me that when you have a number in the front of the log, you can move it and basically use that as a power of a product. So that to move here to become a product. So let's write it out. So log of 2, 8 minus 4n minus, and instead of that 2 here, it's going to become power here. So log of 2, and then n to the power of 2, and that equals 2. So now I can, oh, there is not what I wanted to do. Oh, what happened here? Bit of confusion. Let's delete that. Okay, so now I can use that second formula here. So again, how does that formula work? My A is 2. So now I'm going to have A. So I'm writing instead of 2 logs, 1 log. And that A, that base is my 2. Okay, so that's my 2. Now, what happened? We take the first product, and that's on the top of the fraction. So fraction line, and my first product is that one. So I'm going to have it on the top of the fraction. Then my second product is on the bottom of the fraction. So that's my second product, and that's going to be written on the bottom of the fraction. And all of that now still equal 2. So now I have the base, the product, and I have the power. So I can implement that change when I take the base to the power, and that equal product. So my base is 2, my power is 2, and my product is this fraction. So that way, I don't have log anymore. Okay, so again, how do I solve that? Well, I have a letter in the denominator. I'm trying to find that letter, and removing the letter from the denominator is only one way. I have to multiply by that denominator, but if I multiply one side of the equation, I have to multiply the other side of the equation. So here I have 2 to the power of 2, which is 4, and multiply by n to the power of 2, and here that simplify out, and I have 8 minus 4n. Now I'm saying, I have a letter to the power of 2 in my calculation. What am I thinking about? Minus b formula, of course. So that's my letter to the power of 2. That's my letter. In order to use minus b formula, first, I need to have everything on the same side of the equation. Doesn't matter which side. I decided to move that for n, therefore change the sign, and the rest of the values are written. Then I write my formula for, where are you? For a quadratic equation. One of your best friends you're going to use the most throughout your exam. So now let's replace letters with numbers. So b is the number that stands beside x with no power. A is the number that stands beside x with power. In this case, n doesn't matter. C is a number at the end without x beside it. So minus, the b value is minus 4, plus minus, then a square root, again value of b, which is minus 4 to the power of 2. Make sure that when you are putting it in the calculator, your b here is in bracket. Otherwise, you're going to get the wrong answer, the error, isn't it? And then 2 multiplied by a, which is minus 4. And then we put that in our calculator, and we get 2 values of n. One thing that we have to remember about minus b formula is what? That always check if both answers are applicable in the context of the question. So what was n we were looking for? Let's go back to the beginning. So here, first of all, n here is a product. Here it is a part of the product. And apart from that, here we have that n has to be greater than 0, meaning a positive number, isn't it? Why? Because here the log is not defined for products that are negative or 0. That's why always when it comes to log, our limitation is going to be product cannot be negative or 0. Therefore, here, that's not an applicable answer, isn't it? That's my answer here, n equal 1.